Hello everyone and welcome to a video introduction to the Neo Blockchain Toolkit for VS Code. Joining us today is Harry Pierson. He's the chief architect from the NGD Seattle office and the creator of the toolkit, who's going to be showing us around today, alongside Ricardo Prado, who is a member of the Neo core development team, who will be helping add a little bit more color to this video and hopefully asking some interesting questions. Do you two want to introduce yourselves a little?
Sure. This is Harry. As Edge mentioned, I am the chief architect for developer tools for the Neo project. I'm headquartered as part of Neo Global Development Seattle. I've been working in this community now for, well, as of the recording here, for about 6 months. I joined back in June, though I was working with John Devidos and Peng Huang, who are my partners here in this office, for about 6 months prior to that. And I'm really excited about this opportunity to show off some of the stuff that we've been building here in Seattle.
Okay. Hello, I'm Ricardo. I'm a core developer from Neo team. I'm joined like in around 2018. I'm very interested in developer tools because I actually started to develop on Neo because of the C# smart contracts. So today I'm very excited after maybe much more than 1 year to be able to see that we are building this progress on this this particular subject in the new ecosystem.
Cool. So Harry's going to take us through the blockchain toolkit and just give us a little introduction about what you can do with it today and maybe what he's got planned in the future. And Ricardo will be here to weigh in a little bit on the developer experience and maybe ask some interesting questions. So Harry, I'll take it away.
Sure, thanks. So the Neo Blockchain Toolkit is a collection of tools for building, for Neo developers who are building smart contracts or other decentralized dApps on the Neo platform. It is primarily an extension to Microsoft's Visual Studio Code environment. You can see here on the screen is the link to the Neo Blockchain Toolkit itself. If you install this, it will install 2 other extensions. One is a visual tracker. If you're at all familiar with things like NeoScan or NeoTracker, it's that, but running inside of Visual Studio Code, as well as a debugger, a full-featured debugger. It currently only works with C#, but one of the things that I'm going to be working on going forward, as you mentioned, future work, is working with the other languages in the Neo ecosystem so that all the various languages can support and can emit the debug information. In addition to these visual tools that plug into the IDE, there's also some command line tools that you can install. If you go to the Blockchain Toolkit homepage, there's a quick start. If we click on the quick start, and it'll explain to you how to install these command line tools. NeoExpress is a developer-focused sibling of, say, Neo CLI or Neo GUI. It's a full node Neo blockchain instance specifically designed for debugger for developers. Neon DE is a fork, a temporary fork. We're going to be merging this code back into the main core Neo code base, Neon code base. Neon is the Neo compiler for .NET. This is the fork that includes the debug information. Since it's not finalized, we're distributing it separately. And you can see here, there's also, we have some simple templates. That list is pretty small right now, but we want to expand it out to support more .NET languages and more scenarios for starting your contracts. So let's start with that. We're going to start with a simple hello world. So let's move into this other directory that I have got ready for it. And I'm going to just open up the Visual Studio Code IDE, and you'll notice that the folder is empty. There's nothing in this folder right now, right? So we're starting completely from scratch here, right? So I'm going to come back to the command line, and I'm going to use .NET New. This is the standard way in Visual Studio, in the .NET Core ecosystem, to create a new project from scratch. Visual Studio, the big version of Visual Studio, if you will, has a separate template engine, and we actually already have in the Neo community a template plugin for that. Over time, my understanding is that Visual Studio will be adopting this same template system. So these templates that I'm about to show you now will work with a full-blown version of Visual Studio at some point in the future. But for now, we have to do this on the command line. And I'm going to say Visual Studio, I'm sorry, .NET New Neo contract. And I'm going to come back over here, and we'll notice that it has generated 3 files. It has generated the C# file, it has generated a project file, and it's generated this special build targets file. I actually have to modify this build targets file really briefly to say I want to use that fork of Neon, not the standard version. Anyway, so here we have a simple smart contract. This is the default Hello World smart contract that you get for Visual Studio, that you get for Neo, excuse me. And you'll notice that if I got this, I can actually just immediately go and build it. I'm going to go up to Go, and I'm trying to remember where the command is because I normally do this with the command line. And you know what? I'm going to configure a build task. It doesn't do this by default, but as you can see in Visual Studio Code, it's very simple. It turns out we also need to do the publish command, not build. Now I can hit that, and it will automatically build the code. So now I'm, again, completely inside of this. You can see down here that it's building. It'll just take a second. We can actually open up a terminal and see that task. And you can see here that it's done the NuGet restore, it's done the .NET compile, and then it's launched the Neon compiler to create the AVM file that contains the binary of the smart contract. You also notice that it outputs abi.json, that's standard in Neon today, and it outputs this other file, debug.json. That's the custom information that's only in this fork right now. Again, that information will get eventually merged back once we finalize this format. So now that I have this, let's see it in the debugger. I don't actually want to deploy it or anything. I just want to run it inside the debugger. The debugger has a completely isolated version of the virtual machine that Neo uses to execute its smart contracts. So you don't actually have to have a blockchain up and running in order to use it. So I'm going to go over here to debug, and I'm going to say add a configuration. It's going to take a second while it activates. And you'll notice that I have a list of different ways that I can debug different types of debug launch configurations. And one of them is Neo Contract. So I'm just going to pick Neo Contract. I'm going to close this window down, and I'm not going to upgrade PowerShell. And you'll notice that it's automatically discovered that I have an AVM file. It's automatically going to provide a path to that. And it configures these other settings, which we're going to talk about a lot over the course of this video, but we don't really need for this Hello World contract. And then I'm just going to hit go. And it's going to fire up, and it's already started. So it's been what, 2 minutes? I created a project, I compiled the project, and now I'm running it in the debugger. So this is the standard Visual Studio Code experience for the debugger. One of the benefits of building on top of Visual Studio Code is that we didn't actually have to design this debug experience. Microsoft has already done this work. All we had to do was teach Visual Studio Code how you do things like step or retrieve variables or those kinds of things. You can see that we have a call stack here. In this example, we only have the single function, so this call stack isn't very interesting. And I have some extra information here that's from a previous run. I'll delete that for now. The most interesting thing here is we have locals, of which there are none, and we have this thing called storage, of which there is none right now. So let's step through. I can just step into this code. And so this is just going to write, this is a very simple function that's going to write hello world into the contract storage that's associated with this contract. And as I step, you'll notice that suddenly I have this information here. I see there's now a value that's been written into storage. We can have as many different types of variable containers here as we want. For Neo contracts, we have local variables, and we have the stuff that's in storage. Now, because this is an isolated version of the VM, this isn't real storage. This is just being saved in memory. As soon as this debug session ends, it gets thrown away. But that allows you to always have the exact same configuration every single time you run the project, which is really important for debugging. If I expand this out, we can see that we have some information here. This is a bunch of hex data. This isn't very easy to understand. So let's re-expand the watch window here. And one of the things you can see is that we can actually, we can put this here and we can see that same value in the watch window. That's not very interesting. But what we can do is we can edit this expression and say, you know what, that's actually a string. And so now I can see that it actually expands out and shows me the value of the string. And I can do the same thing for the storage value in addition to the storage key. This allows me to be able to see the data the way that I understand that it's supposed to be treated. I don't have to treat it as a string. If I want to, I can say, you know what, let's treat this as a byte array. And now it's going to expand out and show it as a byte array. So I can actually see each individual value of the byte array. Or I can say, you know what, this is an integer. So I want to treat it as an int. So now that's the integer value of this. This is Neo uses big integers under the hood, so this could be arbitrarily large. It doesn't have to be, scoped down to the size of a traditional int or anything like that. And I can also say, it does this by default, but I can also say I want it in hex value, and it'll just render it in hex. As you can see, that's this. Right. So, and as I mentioned, if I step again, the debugger shuts down. But if I start it up again, we'll see again, we start at the beginning, and again, storage is now empty. And you can see that these values that were from the last run don't have any values and sorted in them. But as we step through, those will show up again just like they did before. So again, part of the point here is that every single time we run debugger, we have automatically got a set state. So that way we get the same behavior. If you were trying to run this against a real blockchain with real data, it gets really complicated very quickly because the data is changing. Especially if you do something like, give me the current height of the blockchain, and the current height of the blockchain is different at the beginning of the contract and the contract. That doesn't happen in production, but it would happen in a debugging session. So having this isolated environment gives us a lot more control over the experience that the developer has.
What if someone wanted to do some debugging with, say, like they're doing repeat invocations, if they want to have that storage be persistent?
Oh, so you could. Right now, there's not really a convenient way to do that. And so please remember that, again, I've been at this now 6 months, and in addition to building the debugger, I've also built NeoExpress, which we're going to talk about in a little bit. So what you can do is that you can use the NeoExpress to set up state, and we'll see that in a little bit when we get to the CNeo demo. But you can also configure this information. If you remember, let's shut this down. In the launch.json file, there's this file called, setting for storage. And so you can actually configure that so that way you can pre-specify storage. Mm-hmm. Let's actually see that in a different sample. So we're going to walk away from the Hello World sample. Interesting. And we're going to use another standard sample from Neo Global Development Shanghai. This is the README. We don't need this. Let's just close all these windows down. This is the domain sample. So this is kind of like a little simple domain registry type of example. So in here, I have this is a very standard pattern in Neo where you have a main function that takes a string and a collection of arguments passed in as an object array, and then it will then switch based on the string that's passed into the operation and do a cast on the data values. So what we're doing here is we're actually going to store this information in storage, where we actually want to be able to say, I want to get key value information out of storage. This is a very simple example. Mm-hmm. Now, you will actually want to run this in a variety of different ways. And so what's interesting about this is that we actually have multiple configurations. Now, this I had to do copy and paste to create by hand. Right? When I did this originally, it called this, domain.avm. And you can see here that the domain.avm link is here. So there's a couple things you notice about this. First off, I'm going to provide arguments. So in the Hello World sample we just saw, the function took no parameters and returned no values. Now we actually do take values and return them. So we want to be able to say, these are the values I want you to pass in. In this case, we're going to query for the owner of the neo.org domain name. And we want to get that value back as a string. The way the Neo VM works under the hood, a lot of values are treated as byte arrays, and string is not an intrinsic type in the virtual machine. So this is just a way for the developer to be able to say, I want you to show me instead of as a byte array. It's kind of like what we saw with the watch window, except this is going to show up down here in the debug console. Mm-hmm. So if we go through and we run this, you'll notice that now this is already configured. You'll see that I actually have 4 different configurations. And let's delete these because those are from the last time. We're going to start with query empty. So we're going to start with empty storage. So as we walk through this, we'll see that we can step through. Let's do this first off. We can set a breakpoint. I don't want to walk through all of this switching code. So Now I can just hit continue, and it'll stop right there at the breakpoint. And it's going to query storage. And you'll notice here, by the way, that we have locals. So we know, for example, that the domain is a string. We know this information from the type. And we can see that there's also this byte unnamed variable called byte array 0. That's going to hold the response of this storage before it gets returned. That's an intrinsic variable that the .NET code creates. And it's just an empty array. And there's nothing in storage. Excuse me. So now as I do a query, it's going to go off and say, hey, what's the value of this domain? Well, storage is empty, so there's nothing in there. And so it's going to return that. And you'll notice here, it returns nothing, right? So we now can also get not only inputs specified in the launch.json file, we can also get outputs specified in the debug console. So let's do something a little more interesting. Let's go to query full. If we bring up the launch debug configuration for that, you can see that our arguments are the same and our return types are the same, but now I've actually specified storage. I can specify storage either as strings or as hex encoded byte arrays. So I could do something like, 0x7, A8D7, whatever, right? I don't actually want to do that in this context. So, but I can actually, so this comes back to the question that you were asking, Edge. I can automatically pre-configure how I want the storage to look. Mm-hmm. And that way I can say, gee, on the first run, do this. On the second run, I want the storage to look like that. So that way you're still not having to deal with a real blockchain instance or anything like that. Still create that kind of experience directly inside of this environment.
Cool. Rick, did you have something to say earlier?
Yes, I have many questions. I don't know if I should interrupt you or if I should wait to the end.
I say just jump on in. Just jump on in.
I'm just the one running this, man.
Okay, so one thing that I would like to know is when you added the watch variable, I would like to know if it's possible to create this kind of custom deserializer. I'm saying this because usually when you're using storage, you add a prefix. So usually add a byte at the beginning, and then you put the data or the key that you're using. And depending if you do this and you just convert it to a string, you may get a weird result. So I would like to know if it would be possible to using the watch function from VS Code to build a more a print function in the watch that I can divide my binary array, my byte array. Maybe the first byte I want to see as hex, the second one, the next ones I want to see as a string or something like that.
So I'd like to point out real quick that if we go to the Neo project GitHub, there is a link for the debugger somewhere in here. There it is. And in the debugger is this nice tab called issues, of which there are only 2. And I have filed, well, one of them is me and one of them was Lights. So this would be a great place for you to go, Rick. And as you start thinking of things you would like to see, it does not support that today. That sounds like a great feature request going forward. Today, the list of evaluations is a hard-coded set that are built in. I can totally imagine the ability to support in certain types of contracts. We're kind of jumping ahead here, but let me just since I can answer your question. In the CNEO contract, we're going to look at in more detail. You'll see that there's a type called transfer info. So this is actually a struct or a class where you specify information about, what's the from, the to, and the value of a CNEO transfer. So you could totally imagine being able to say, hey, in the watch window, I want to treat this value as a transfer info and have it automatically, if assuming we put this information about this type in the debug information, to be able to extract this type information so I get a nice friendly view. Is that the kind of thing you're talking about?
Yeah, exactly. Maybe kind of implements the TrueString, maybe something like that.
That would be
right?
another. Actually, implementing TrueString would obviously be another really great. So again, Neo project, Neo debugger issue. Go file it. While we're waiting on it, you can do it after the call, right? Don't do it now.
Yes,
Rick loves creating issues.
But you'll notice here that I have filed this thing because I am trying to think through ways to make that launch.json file easier to work with. And in fact, it turns out I actually wrote and I created this Oh no, it must. Oh, it's in NeoExpress. That's why. There's a feature that I added. I had to do a small bug fix for NeoExpress yesterday, and so I added a feature while I was at it. So I opened the issue, did the feature, and closed it. So I'm going to be living. Obviously, there's not a lot of bugs in here yet. We just shipped this publicly. We just shipped the source code publicly. But I am very much looking forward to folks in the community filing ideas and improving this. One of the things you'll notice, by the way, in both the Neo Debugger and the Express is that there's a section in the README called a message from the engineer, which basically says the TLDR version of this is, I built this myself and I'm very much interested in getting other people's opinion about how it should work. I only have my own perspective. So I'm looking forward to both of you and other folks in the community providing feedback on all of these various tools. So let's go out of this for now and back to...
I have a few other questions.
Okay, go ahead.
It's just one very quick. It's just I noticed that we have this storage, and this storage is not persisted. So what I'm asking you, what I would like to ask is it planned for the future to allow the debugger to call other contracts? Because, for example, it's very common for you to have the need to deploy more than one contract, like one thing, the other, like authorization, the other is going to manage the other part of your system. So I would like to know is it planned for the future for you to have this smart contract being able to call another smart contract, because this depends on the storage.
Yeah, well, so it's completely so it doesn't do it today, right? Today you can only debug a single contract. If that contract that you're calling is yeah, I don't think that would work at all today, to be perfectly blunt. But one of the benefits of having the support for blockchain data that I'm going to show when we look at the CNEO example is that we actually have a real full-blown blockchain, including the information about other contracts. So if you want to debug through multiple contracts, that's going to be different from I'm going to invoke a contract and just get the answer back. I'm not sure yet. In the scenario you're talking about, do you want to debug both the caller and the callee, or do you just want to debug the caller?
I think you want to debug right now. However,
you cut out there for a second. I missed your answer.
Sorry, it's a little noisy here. So I think that you only want to debug one contract per time, right?
Yeah.
But I think that when you have this, when you're invoking external contracts, it's a very common use case, because when you want to...
Yeah, no, we absolutely want to support that. Again, if you want to file an issue on that, that would be great. But I absolutely want to support that. We just haven't gotten.
Sure. Okay. So I'm going to move to the next question. It's not a question. Maybe it's just going to something that I will add to GitHub. Is that I would like to be able to see the stack of the VM, because sometimes for us the core developers.
So hold on. Let's go back and see this sample again. Tell you what. Let's skip. Give me a second on that one, okay?
Okay.
So now let's look at. We saw a query empty configuration. Now we're going to run the query full configuration. And this time we're going to actually specify storage for, we want to specify some data that's going to be stored in contract storage, emulated storage. So I say run, and you'll notice, by the way, here, real quick, that we have a call stack. The way the Neo VM works, there's sort of a little preamble that doesn't have a name. That's essentially push the parameters onto the stack and call the main function. And here we have the main function, that's where we're at. And I'm going to, again, because I've actually already put a breakpoint, I can just hit run. Oh, no, actually, real quick, you'll notice that I actually have storage here. So if I add this to watch and treat this as a string, this value is neo.org. That matches the value in here. And if I go and add this to watch, and again, it treat it as a string. All right, so you can see here that from the perspective of the virtual machine, I actually have things in storage at the beginning of the contract. So now I'm going to hit go, and you'll notice here that it's in the call stack, right? So now I can see that I'm in the query function, which is being called from the main function, which is being called from from that unnamed preamble. So you can already see this here today in the debugger.
Yes, but I'm saying more like at VM level, Neo VM, not the call stack. Something like to see the opcodes in each of the stack.
Yeah, that's another common thing that's been asked for. What you're talking about is what's called the disassembly view. And
yes, exactly.
The underlying protocol that Visual Studio Code uses to communicate debug adapter supports that, but Visual Studio Code does not yet. So once Visual Studio Code adds that feature, we should be able to add. So you're not talking about the stack. What you're talking about is I want to see the Neo opcodes that go with this C#. Right?
Yes, exactly.
Yeah, no, I have plans on that, but again, unfortunately, right now, Visual Studio Code doesn't really support that. I suspect that because they've added that to the underlying protocol, that we will see it at some point in the near future in the product. But until then, I've been focused on other features.
Yes, sure. Okay. Let me see.
You have a lot of bugs to file, Rick. I don't know if you know that. I'm gonna have a lot of work when you're done. So.
Also, just one last thing is that now the Neo compiler supports compiling directly a CS project file, and I think it's going to help you a lot because you can make like the publish function easier because you can call the CS project, and because if I saw the way that you're doing today, it's not going to work with multiple files. I don't know if you have planned it before, but the compiler has been adapted this week to support the CS project file along with multiple source code inside.
Is that for both Neo 2 and Neo 3 or just Neo 2? Just Neo 3.
I think it was added just for Neo 3, but it can definitely be added for Neo 2 as well because it's
Let's talk about
outside.
that offline.
Yes, sure.
Okay. So anyway, so real quick, let's finish back in this demo. So now you can see that here we actually get that we're going to actually retrieve the domain, and we can actually see that there is actually a value for neo.org. So as I step through, you'll now notice that this byte array has a value. Again, this is an unnamed. This is basically where the return value goes. And again, as you can imagine, if I put this in here, this is going to be Neo Foundation because that's what I stored in the data storage. And then finally, as I step out, I need to bring my debug terminal back up because I've closed it down. You can see here that I actually get that return value here in the debug console. So I'll get information. If I get a fault in the VM, it'll pop up here. If I raise an event, it'll pop up here. If I log something, it'll pop up here. And then, of course, I get the return. So now let's look at one more interesting example is register. So here I want to actually create a entry. So I've queried now twice, and you can see that there's transfer and delete. We're not going to walk through this today, but we are going to look at register because there's one thing I want to show in register here. So again, here I'm going to say that neo.org is going to register the Neo Foundation, the Neo Foundation is going to register neo.org. And one of the things that's featured in here, and we're going to set a breakpoint, is you'll notice that there's runtime check witness. The very first feature that Rick suggested for me in this debugger was to make it really easy to set the value of this. So if we go back to launch.json, you'll notice that I have this code here that allows me to specify who the witnesses are. So here, I've basically hard-coded it to say, hey, if you call check result, always return true. I can also mark this to be false, or I can provide a set of witnesses here that it will be checked against. But for now, we're just going to treat it as true. So now we're going to call the register succeed function. This is going to work very similarly as we saw before. We have empty storage. I'm going to try and get the current value. The current value is an empty byte array, which is treated as null. You'll notice, by the way, that I can, so no, that doesn't happen here. So it says return false. It does not return false. And now I'm going to actually update the database, update the blockchain. You can see here that information is here in the blockchain. It's using the same, this value is generated from the key, but it's obviously significantly shorter. So no matter how long the key is, this is always going to be a 32-bit, a hex encoded 32-bit number. So that way, and it's stable. So that way it's the same between passes. And it doesn't like become huge because otherwise you wouldn't be able to actually read the value here. And as I exit here, we see return true. The final version, we're going to try and register here. I'm going to try and register neo.org, but Neo. So this time it's going to fail. This is just one thing I want to show in this. We actually have the ability to see breakpoints in the middle. Like you'll notice here, we're going to check value, make sure that if the value is not null, we're going to return false. You see the value here, it's not null. So we can actually stop directly on the return statement, even though it's. So this debugger has got a really great experience, and we inherit all of this basically for free. So, and the other thing that's really nice here is that the debug protocol, the Visual Studio Code used to communicate with the debugger is also supported by other IDEs. So we will hopefully be able to support full-blown Visual Studio on Windows, as well as Visual Studio for Mac at some point in the future. Eclipse actually supports it, so if the Java folks want to, the Java Neo Java folks want to support this, they'll be able to do so. And other, I would imagine other IDEs are coming on board with this as well. So that's the simple sample, and you can see here return false for the domain sample. So now let's go look at a more interesting, even more interesting sample. This is the CNeo code. So CNeo is going to be interesting for a couple of reasons. Among other reasons is that we are actually starting to use NeoExpress in this example. So for those of you who aren't familiar, NeoExpress is a command line tool that allows me to have a running instance of the Neo blockchain locally. So if you've ever seen, like, Neo local requires you to have like Docker and containers and all that kind of stuff, or there's a quick start that isn't very quick from Neo Global Development Shanghai. It tells you how to set up Neo CLI in a configuration for this. As an example here, let's just go back to let's go to back to the hello world just to demonstrate a few things. I can create a NeoExpress blockchain this quickly. Boom, I'm done. And now let's actually run it. This is creating a 1-node blockchain. You can create a 4-node blockchain or a 7-node blockchain if you want. You can run them on separate nodes, or you can run them all on a machine. It's primarily designed around the 1-node. There's a variety of features that NeoExpress supports that you would never do on your production blockchain. So for example, here we've generated a series of blocks, 1, 2, 3. I'm going to shut it down. And if I start it again, you'll see that we'll start again. We're still the 3 block hadn't finished, so it's going to stay at 3, move on to 4, what have you. I can also say I want to reset. So this is going to throw away all the existing data. You probably don't want to do that on mainnet or testnet. But when you're doing debugging, you get yourself into a messed up state, you can start over again. Another thing you can do is you can run it at different speeds. So I can say seconds per block. You can also just say -s. And I can run this chain a lot faster. So as you'll see here, after the first block always takes a little longer. You can see here that it's generating blocks a lot faster. This is great for both generating gas that you'll need for doing certain operations on the blockchain, as well as, like, I don't have to wait 15 seconds for my transaction to complete. I don't have to wait a second. I can also do things like I can create wallets. This I can do offline. So I've now created a new contract. And you'll notice, by the way, it says very, very specifically here, these private keys are not encrypted. And because this is a development scenario, I didn't want the developer stuff. I don't know about you guys, but when developers have to maintain passwords for development environment, they invariably choose something unsecure like password. So I just got rid of that entirely for these kinds of contracts. All the information about the NeoExpress instance is running inside this default, this file. By default, it's called default. This is the information about the consensus nodes. Here's the information. This is stored in a custom format, but if I really want to, I can actually export. And now I just have a NEP standard wallet file. If you're, okay. If you're at all familiar with the NEP standard wallet format, this should look very familiar. So what's really nice about this is I can actually use NeoExpress with Neo CLI or Neo GUI. I can take this wallet file and I can open it up in Neo CLI or Neo GUI. I can even export the entire blockchain. I can just say export, and it will go off, and it will create a wallet file for every node. It will create a config file for every node, and it will create a protocol.json file. So you can actually now open this blockchain completely in Neo CLI. The data formats between the two are not compatible. So you can't take the blockchain data from Neo CLI and open it in NeoExpress or vice versa. But you can connect the NeoExpress instance to Neo CLI by sharing this protocol configuration file.
Let me ask you a question. So
Yep.
I'm seeing the configuration that you're using for the single node configuration. However, this configuration seems a lot simpler than the configuration that I was trying here to run a single node. So this protocol is just to connect NeoExpress, right? It's not this protocol there is not able to start a consensus node with a single node using only this information, right?
It absolutely can. I can take this protocol config file, open it up in NeoExpress at Neo CLI, and it will. So if I have NeoExpress running as my consensus node, and I take this protocol.json file and stick it in and use it with Neo CLI will connect to the NeoExpress node, sync all the blocks, and as far as it knows, it's just another full node.
Yes, but the question is, this is not enough to be a consensus. For example, if they standby
no, this is not a consensus node, but this config file, this is. So if I want to take if I want to run a consensus node with these wallets, I can do that. Now, the problem is as soon as you create you have to, because they use different data formats, you can't easily move the data from NeoExpress into Neo CLI. And because you pretty much have to pick the validators at the beginning, like you have to define these at the start. So I don't know enough about how you run, like add different validators or different consensus nodes. I'm just not familiar with the DevOps side of running mainnet. So whatever's feasible there, we can add to NeoExpress, but it doesn't support it today.
I see. No, okay, it's just because my configuration file is much bigger, but that's all.
Well, I don't know what else you have in it. So again, this is not configuration, this is protocol. Configuration is bigger.
No,
right?
No, it actually is for the protocol. It's I don't know. It's I have to check with the guys from New Research.
Well, remember this is a one node one, right? So if I come back, just let's well, we don't really need the hello world, so let's just delete everything here. If I go back and say I want to create a wallet, now I've created a 7-node account, and if I go and export it, now here you end up using the same password for all of them. Again, this is for development purposes, so we can obviously change that going forward. That's a much longer protocol file, right?
Yeah. No, but it's something different. But don't worry, I will check later. But it's
Okay.
good to know that you can export this because it's very complicated to have an agreement with all people to have all the files with for development purpose, of course. If someone can in a single place generate all the configuration files and then distribute this file, this can easily help us when we want to, for example, create a distributed network for testing using AWS or another cloud provider, because the files are going to be generated in one place.
Yep.
Much easier.
So let's go back to just creating a single node one. And I've deleted everything, so I now need to recreate the RickLock wallet. Oh, hey, what if I actually say create? That would be useful. So as I was mentioning earlier, we store the private key in the clear, and you'll notice here we have, this is the main node private key. This is the consensus nodes. personal account. There's also this account, which is the multi-sig contract. So this is that consensus node contract. And then we have information about wallets here in the in that same file. So I can also, once I actually have this up, you know what, let's do this. I'm going to say NeoExpress run, and I'm going to run this at 1 second per block, so that way it's very fast. And now that it's up and running, I'm going to open up a terminal window here. This is the same base. I'm just opening up a different terminal window in that same folder. I can use this to do a bunch of like sort of maintenance of things. Like, so I can say, I want to transfer, so NeoExpress, transfer Neo, let's say 10,000 from Genesis to Ricklock. So again, normally when you do a bunch of this type of operations, you have to use this script hash. You know, so Rick's in this example is ADXU blah blah blah. So here I can actually just do this by nicknames. Genesis is a special nickname that refers to the Genesis, the Neo that's created by the Genesis block, and that's this multi-sig account here. So if I execute this, it's going to dump a bunch of JSON to the console. It's communicating that with that running instance of NeoExpress window. And now let's do this. I'm going to open up this window and get the visual tracker so we can actually see this in action. So it just takes a second. So first off, you'll notice a couple of things. First off, I can actually view mainnet. So conveniently enough, I can actually just, even if I don't actually have a project up and running, I can get some information. I can see what mainnet looks like. Here's the latest block on mainnet, all this information. I can see the miner transaction. I can see the invocation transaction. I can see the bytes that were there, what have you. This is pretty simple today compared to things like NeoScan and NeoTracker, but this has been available for a couple of months and those projects have been around for years. So this will continue to improve over time. I can also connect to testnet if I want to connect to testnet, but you can also notice here that I have it able to connect to my local node. And you'll see here that these are coming up very quickly because I'm running this every block every second. If I click on one of these, we'll see that it only has a miner transaction. Because I'm running this so quickly, it isn't really giving me, there's a lot of noise here that I really don't care about. So you'll notice that there's this thing for hiding empty blocks. There's only 2 blocks of interest so far in this blockchain. The initial block, of course, this is the Genesis block, so it has the Genesis register transactions and the issue transaction that creates the Neo, creates the gas, and assigns it to the Genesis account. There's also then block 57, which has a contract transaction. So this is the transfer to the Ricklock account. So we can see here that we had 100 million. Now we have 10,000 for this account. I can click on individual ones and get address information. I can go back to the block that was generated. So this is very standard tracker type of information, but here running inside of Visual Studio Code. In fact, what's also cool here, let's shut these windows all down. I'm actually going to shut this down for now. I'm going to come back over here, and you'll notice that there's a play button. So now I'm actually running this in the context. I don't have had to create some other separate window. And as you'll see here, now this is running at 15 seconds a block, so this isn't going to be running fast. But you'll notice here when this one finishes, any day now, there, 189. Again, we can hide the empty blocks and what have you. So I can actually control this node from directly inside of the UI. You can imagine that all of the things that we currently do on the command line with NeoExpress, we are going to support via this UI. We're not there yet. Today we only have start and stop. The development branch has invoke contract, and there's a PR out for create. So I want to be able to create this NeoExpress from inside of this UI, but those aren't ready yet. But we're going to continue to work and improve this over time.
Will you have checkpoints down there as well?
We have checkpoints, but not in the not in this UI yet. So you were just saying about checkpoints. So let's come over here and say NeoExpress. We're doing the opposite now. Now, instead of running the Neo is now running in Visual Studio Code. So, actually what I can actually do is I can just open up and go back to this example and say NeoExpress. And just as a quick aside, I can say show unspent. So NeoExpress implements the system tracker plugin. It has to be a completely separate implementation because it's data store. But this allows tools that already know how to talk to the get unspent and get claimable. You'll notice this is just that same JSON that those things dump off. So I can get information about unspent and those kinds of things. And I can also then create a checkpoint. So if I say NeoExpress checkpoint create, and we're just going to call it CP1. Now, because this is running in the background, I also have to add online. So you can create checkpoints either online or offline. As of right now, you have to tell it explicitly. It doesn't know how to, it can't tell whether or not it's already running or not. So I'm going to tell it to create it by hand. I'm going to tell it to create it. So that's sending a message, and it's now created this checkpoint right here. So if we come back to this window, we can see that we're on, actually, you know what? Let's go to here. We can see here that we are on 198. Let's give it a second because it's, of course, running. This is why I tend to run my blockchain at 1 second per node because this takes too long. So now I'm going to shut it down. And I'm going to come back to here, and I'm going to run that. I'm going to be able to do a couple of things with that checkpoint. So if I say NeoExpress run, it'll pick up where it left off, block 200. We'll let it run for a couple of seconds here, create a couple more blocks. So now we're on block 205. If I start it again, it'll be at 205. I'm going to shut it down again real quickly. And that's just because I was shutting it down. So now I can say NeoExpress checkpoint restore CP1, and I have to tell it force because I'm overwriting data. So now when I go back and say run, we'll see that it's not at 2, it's back to 198. Now this is updating, so I'm going to let it run again for a few seconds. And if I run it again, it'll be still at 204. So now I'm going to do the other thing you can do with checkpoints. And this is what becomes really valuable when you start talking about the debugger is, so this checkpoint is essentially the state of the blockchain when you invoke the checkpoint. NeoExpress uses RocksDB instead of LevelDB, which is part of the reason why the files are not compatible between NeoExpress and NeoCLI, the blockchain data files. But using using RocksDB gives me two big advantages over using LevelDB. The first is that RocksDB is distributed via NuGet. So as a developer, if I'm checking out the code and experimenting with it, I don't have to do anything special. It automatically brings down the RocksDB dependency automatically from NuGet. I don't have to deploy it manually the way I have to with LevelDB. But more interesting from a functionality perspective is I can do online checkpoints. So when I did this online checkpoint, it sent an RPC message to a custom RPC endpoint that NeoExpress supports that says, create a checkpoint and put it in this file. And it's able to create that checkpoint even though the blockchain is running and save it to that file. The file is just, as you can imagine, is just a zip file. So if we actually, if we just open up this folder and we say, gee, I want to open this with, say, a tool like 7-zip, it's just, this is all the information about the blockchain. These are all RocksDB files. It's just a zip file. This is a very common approach to collect a bunch of files into one archive. And when you go to restore it, it automatically deletes all of your existing ones and uncompresses this into the temp folder that's using to store this information. I can use this information, not only can I restore it the way I did earlier when I said checkpoint restore, I can also say checkpoint run. So now what it's going to do is it's actually going to open up that the files that are in that archive in a read-only format. So now I forgot to add here. Let's we'll talk about it for a second. So any changes that get made, every block that comes along, is only being stored in memory. So when I shut this instance down, it will automatically throw away all of the data that I've done. This is fantastic for both testing and experimentation. Like, I want to test deploying my contract and it's failing, and I want to keep testing it and modify the contract, run the test, modify the test. In a real blockchain, that would be a pain in the backside, because every single time you go to deploy it, you've now got the wrong, if you've got a bug in your contract, so the deployment succeeds, but the contract itself is wrong. You have all these extra copies of the contract running around. Here, you can always roll back to some existing state. So if I shut this down now, you can see here that we were at block 202. Whoops, I actually have to use the command correctly. Now we're back to 198. All of the changes between 198 and 202 were automatically disposed of when I shut the blockchain down.
So let me ask you something, Harry. Do you
Please.
think that we can use this checkpoint structure with the JSON and create some kind of more complex tests, ensure that the blockchain is working? Because I know that the issue that we always have is, if you use your local server, it's much faster to develop. However, you cannot share this state with someone. If you want to, I have my colleague here is going to continue my work, but he doesn't have the blockchain there. So do you think it's possible for us to use the JSON that you like, the launch configuration, maybe do some tweaks, and also with the storage, and create some kind of JSON test saying, okay, using this database image and this test, the result should be like this. Do you think this is feasible?
So one of the things that the checkpoint feature supports is the ability to distribute information. So I'm going to do something real quick here. The information about, hold on a second here, local data. So this is just a temp directory that app data stores information in. And if you'll notice that there's a folder here for Neo Debugger and NeoExpress. So these are a bunch of blockchain nodes. You can see here that I have a bunch of blockchain nodes. So these are all the various instances. So what I'm going to do is I'm going to actually delete all of them. Okay. So now, if I go and I run this, if I run the checkpoint, I'm at position 198, right? Because we saved the checkpoint. If I go to run it directly, it starts at 1. And you'll notice it's created a new folder for the information, right? So you can imagine that by deleting this information, this is like, I've now just checked out the repository that has this file checked in. If I say checkpoint restore, and you'll notice I don't have to add the dash force, it's gone off and created this folder. So now when I say run, it's going to start at position 198. So if you go and actually check these files into Git, then when you check out the project, you can immediately start in the exact position that you want customers to do. And in fact, that's what I've done here with CNeo. So in CNeo, you'll notice that I have these checkpoints for these different positions. If I go to the CNeo project and I say NeoExpress run, well, I deleted everything. So this is like a brand new machine that is never starting at 1. So now I can say NeoExpress checkpoint restore checkpoints, and we'll restore the first one just for, and again, because I've actually created one, I have to force to overwrite it. Now when I run it, I won't be at position 2, I'll be at position 299. So if you go right now, Rick, and you install these tools, and you go to check this project out, which is up on the Neo Global Development Seattle GitHub right here, you can do this today immediately and it'll automatically set up the blockchain exactly the way you want to run it. You can either run it as a checkpoint, in which case it throws the stuff away at the end of the project, at the end of the run, or you can restore it like I just demonstrated and get up to a working state immediately. That's part of the reason it's designed this way. So that way you can automatically distribute, like, here's the way you actually want, here's the data that you really want to use when you run this test or when you work on this part of the project.
Yeah, so I think this is extremely, extremely important, because all the time when you're doing this on your local host, it works, but always when you have to share, you always have problems. So you say, oh, so now first you have to register. Oh, now you have to approve. Now you have to do this.
Yep.
There are several steps, and it's going to be much easier. So I'm just going to say, oh, run this using this state. And this will definitely solve a lot of problems.
It also turns out we can use this information for debugging purposes too. So if we look at the CNEO contract, the CNEO contract has a bunch of very simple things like, get me the name, right? So if we go to the definition for this, it's just going to return a string, right? We can debug that. It's kind of stupid, but we can, right? So if we come up here to name and we go, when we want to run this in the debugger, we'll see here that it's just going to jump to the name operation here, and it's just going to return the name. That doesn't require any blockchain information. So if we go and we look at the launch project for name, we'll see that we've added arguments and, oh, whoops, not name, I'm sorry, hold on. You'll see that we don't have any arguments. We know it's a string, we haven't provided data. However, if you go and you say, gee, I want to, let's close these windows down. If I go to contract, you'll see that there's a operation called mint tokens. So in mint tokens, you send some number of Neo as a UTXO transaction to this contract, and it will automatically assign you that number of CNEO net5 tokens. And that's what this code does. This is just a standard sample from NGD Shanghai. If we look at the code for this, or we look at the debug information for it, you'll notice a couple of things. So in mint tokens doesn't take any argument. The first thing is it's actually using a check. So if you look at the code for this, it has to be able to go off and do things like get the references for this transaction. And I need to be able to get the output script hash, and I need to be able to store information in storage and do this other kind of stuff. And I need to raise an event. And I need to be able, in order to do that, I need real blockchain good enough just to have, emulated storage and nothing else. I need to be able to talk to the transaction object. I need to be able to get the transaction references. And you get a good experience with this too. So let's go to mint tokens real quick. Let's actually just run it. Let's see what it looks like in the debugger. And I've got a breakpoint already set. Oh, I've got a, hold on one second here. I guess I did not have. Let's restart this here and set a breakpoint at the beginning of mint tokens. So now I walk into mint tokens. The first thing it's going to do is it's going to say, give me the script container as a transaction. So you'll notice up here is transaction. That's the variable TX. If I open it up, you'll see that I actually get information about the transaction itself. Inside the debugger, all of these different domain models like transaction or block or transaction output, et cetera, each of those has a custom representation that the debugger can then query in order to show it in the variables list. So if you're familiar at all with how NeoVM works, in NeoVM there's a type called interop interface, and it's basically a container for something that isn't native to the debugger, to the VM. NeoDebug defines many different ones of the type that it wants to show in the debugger. That way the debugger knows how to talk to it. So when you look at, say, a transaction, you get information about the invocation and the hash. If I keep walking through and I say, gee, now I want inputs, inputs is a collection of transaction outputs. So I can actually the value and the script hash. And if we go back and we look at the launch, we'll see here's the transaction input. That information is that's the information from this transaction available here in the debugger. And I'm going to go through and check to make sure that these things all match, et cetera, et cetera. I don't really want to get the transaction information right now, so let's step over that. If I go off and get outputs, again, the same kind of thing here. I get a transaction output. These you'll notice match. That's the script hash for the current script. Here's that same script hash here, viewed as a debugger value. This asset ID, in case you don't know, the asset ID of Neo. You can specify it here as a hex string, but it's a lot easier just to write Neo. So if you write Neo or gas here, it'll do that correctly. There aren't really any other types of assets that are UTXO on the blockchain at this point.
I have one question. How did you generate the inputs and the outputs? Did you do this manually, or there was some kind of easier way? Because let's say I'm going to start.
I basically just used get expense or get unspent, right? So if we come here, I'm running this. Hold on one second here. This is the default JSON file. So I have an account called test user. So I've got I have to actually run the blockchain in order to do this. So let's NeoExpress checkpoint run. So I'm just going to run this checkpoint so that I can query. I'm going to come back over here and go to a terminal window. So if I say NeoExpress show unspent test user, I will get the information about, and you'll notice, if I go to the right file, then this will look very familiar. F blah, 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 blah. That's this file. The only thing is I had to add the 0x so that the debugger knew to treat this as a hex string instead of as a normal string. So this is basically, the output. Well, this is Neo, this is the amount, and this is the contract hash. So that information is available in the ABI file. So at the top of the ABI file is this. One of the things that I'm looking at for a next version is this value, this contract hash, changes every time you modify the file, which means all of the storage associated with the contract goes away. So the problem you run into is again, this is back to that same scenario of stuff you want to do in development is different from what you want to do in production. In production, you want to use the hash of the binary value of the contract as the identifier. The problem is, if you use that in development, it's changing all the time. Every single time you make any change to the source code, you are potentially creating an updated hash, which blows away all of your test data and blows away all of your debugging, et cetera, et cetera. So one of the things that I'm looking at, in fact, if you go back to that list of issues in NeoDebug, you'll notice that there is one already there that I filed. No, this is NeoExpress, excuse me, not NeoDebug. Support stable contract hash during development. I want to have some way to be able to, and this bug is closed, but we'll worry about that later. I want to have some ability to have a stable contract while I'm in development. It's not going to work for me to have to change it every single time. I don't know yet how I want to do this. I have some ideas. It's not supported today, but it's painful to develop because every single time you make a change to your source code, all of that hash changes and everything else goes with that changes. So I'm trying to figure out a way to solve that, but it's not in the current release. But this, by the way, if you go just as a quick aside, if you just go to the official Neo docs, reference RPC API, get unspent. So this, it's not part of the intrinsic. It's provided by this plugin. It's a standard plugin. We actually, NeoExpress automatically implements this Neo System Asset Tracker plugin. So you can use get unspent. It turns out this is very common in a lot of libraries. If you want to be able to do a transfer of Neo, like I've been showing in these demos, you have to be able to get a list of all of the unspent tokens. You can see an example here in JSON of these various transactions that have various amounts of value. These are gas. You can tell because they're fractional, and this one is not. So that is all, that's a standard Neo endpoint, and we support that in NeoExpress, so that NeoExpress works well with tools, libraries like Neon.js. In fact, if you look here in this project, you'll notice that some scripts to be able to actually invoke the mint tokens transaction and stuff like that, because you have to, in order to do it on the blockchain itself, you have to be able to do things like add Neo to the transaction, and that turns out to not be particularly simple to do, so it was easier to just write a script for it. And again, as a reminder, I can always connect and see this stuff running in the contract view, in the tracker. Here we have more interesting transactions because we've done more things, so including claims and what have you. And you'll also notice, by the way, we're doing all this while so we're not actually modifying anything in the state of the debugger, and we can now continue to go through and walk through all these things. Another thing, by the way, that you were talking about wanting, or that I'd like to look at doing from a simplification perspective, is if you store information. Right now we don't have anything, put stuff in storage using storage map. So storage map is a standard type that's part of the C# Neo framework for smart contracts that allows you to have a sort of a name value storage. And here we're going to create the get total supply. This is just a standard one here. Here we're using the word total supply as the value. And we can see here the total supply value. Oh, and by the way, you can see here I'm hovering to get the value. It's the same here as it is here, and I can add it back to the watch window if I want to. But when I go to actually stick it in the storage, because I'm using a storage map, I don't get that information, so I can't really see this. This is a custom information. If I add this to the watch window and say I want to look at it as a string, you'll see that it has the word total supply in this case, but the value is going to be, well, I guess this one actually works out pretty nicely. But yeah, it'd be nicer to have some built-in knowledge of how to parse storage maps so that you can actually see these can have multiple values in them. So it would be nice to have that show up here in the debugger view, but it doesn't have that support today. Now I'm going to set the transaction information, and it's going to write some information to the storage map again. So it added a new storage map. And this is the other thing I wanted to demonstrate here. I'm about to show you if we go to the debug console. It's called a transferred function. So this is actually an event. Scroll up here to the top. You can see here that I have the transferred event, which invokes this transaction. As I step over, you'll see here that I actually get that information. So anytime I actually, whoops, that's not what I meant to do. So here I get runtime notify. The name of the notification event is transfer, and then the to it. By the same token, if I call log, I'll get log, and if I throw an exception, I'll get anytime there's a fault, I'll get a notification here of the system fault. So there are a couple of other things I just wanted to demonstrate here, right? So this contract has a lot of different operations. So we've created a lot of different launch configurations. You'll also notice here, because of the fact that invoking these smart contracts of mint token and refund are fairly complicated, I've actually implemented those in TypeScript using the Neon.js library. So this is the way that you actually invoke the transaction using Neon. You create the script, and you tell it the hash and the string name. Mint tokens has no parameters, so you don't have to actually pass any. And then you use this intense thing to say, hey, I want to pass 1,000 Neo in this case as part of the launch. And so this is the way that you do on a running instance of a blockchain. That's the same way as specifying this information in the launch DB, in the launch JSON file. And again, just as a quick aside, this information is the exact same format as you get out of the top part, the inputs, is the exact get unspent RPC endpoint. So you can just, NeoExpress has the show unspent operation, which will show you that information. Mm-hmm. One of the other things I wanted to show was how the, something that's also kind of interesting is the validation. So you'll notice here at the top, there's a ability to specify if I'm doing this code path, and if I'm not doing verification, which means I'm doing application, I want to go down this code path. So we also support that in the runtime. So if I, you'll notice that this class says trigger application. That's the, but you'll also notice I have refund and, so in refund verify, I've specified the verification trigger instead of the application trigger. So if I go back to the debugger and I say I want to call refund verify and walk through this, I can actually walk through the verification script instead of the application script. Again, the goal here is that even though I'm running the isolated environment, I want this environment to feel as natural and familiar as the normal normal blockchain execution environment is humanly possible. That's why we're reading information out of the blockchain for things like transactions and what have you. It's the reason why we use checkpoints. It's the reason why we have emulated storage. Anyway, so you don't have to keep running that. Another thing that was added very recently, 2 days ago, is that, let me see here, where am I? Senior. If I gonna run a checkpoint here. Let's see here. Mint tokens invoked. Yes, that'll be a good choice. So I'm only running that so that I can execute in the command window for a second. If I say NeoExpress, contract, storage, CNEO, this is going to invoke a custom RPC endpoint that'll give me stored in contract storage for this contract. This isn't actually turns out to be a very useful format, but if I do --JSON, it'll dump it out in this format, which as it turns out, I can then turn around and copy and paste into the storage information here. I've done that somewhere in here. I think the mint tokens or get balance of total supply. One of these has, if I can actually spell storage correctly. There it is. So this information about get transaction info, storage information, this storage information, if you'll notice over here, if you notice down here, is the same, right? So U8A. So what's really convenient here is that I can get the checkpoint into the state that I want, and then I can dump all of the contract storage and put it in here. So that way I don't actually have to be running. If I have to run it against a checkpoint, I have to have that checkpoint local. If the contract is changed, and then you run into, I mean, there's a bunch of those kinds of things that come into it if you do that. So this is actually really convenient from the perspective of setting up your data and then putting it into your launch.json file in order to make it more nice and easier to debug. I had to fix a bug in NeoExpress, and so I added that feature while I was at it. And again, if you walk through and look at this, the behavior of this is identical. Get transaction information. By the way, I think this is an example of the kind of thing you were talking about earlier, Rick. I'm going to get this transfer information. I'm going to deserialize it and display it in the debug console. And you'll see here that I get information about, I get some information about the data. This is a transfer information. So I get like the from, the to, and I get the word integer for value. So it would be really nice to have the debugger be able to say, hey, so that way this will return like, hey, I want to actually return this as an integer. I don't want value or the word integer. And so the same kind of idea of if I'm actually debugging through, and let's run this in the debugger again. When I run this in the debugger, I get the information. Let's see here. I get this transfer information, which is currently empty, but as I run it, it's going to populate it. And it's just going to be this array. And it's not, again, I don't really get very much information about what I really want here. The string integer doesn't do me any good here. So it'd be really nice if I could have type information to be able to say, when I see this, I know this is a transfer info. I've got the name right there. So, hey, maybe I should actually have the type information here as well. Mm-hmm. If these were strings, for example, instead of integers, it would be really convenient to be able to show those there. Anyway, so there's still a lot of things we can do to improve the developer experience of this debugger. I think it's a gigantic step forward from where we've been with debugging contracts and with the development experience on Neo previously. But as with all things in software development, there's no end. You just keep going and keep improving things. So we've certainly identified. You have some work to do, Rick, of identifying. Filing some bugs for me of other feature requests you want on this stuff.
Yeah, I will definitely do. I have the list here. It's, but they are features that I definitely.
Well, and I want to make this better, and some of those are things that I hadn't had time to get to, and some of those are ideas that I think it's been made pretty clear. I don't come to this community with a deep background in blockchain. I come to it with a deep background in platforms and developer tools. And so things like your original suggestion to make it easy to stub out the check witnesses value, I added that because that was something you suggested. And I don't know how long it would have taken me to figure that one out on my own. So I'm very much looking forward to feedback from both of you and all of the people watching this video. I'm very much looking forward to adding a lot of features to this code. I'm also looking forward to people who want to contribute to these code bases. Like the rest of Neo, these are all open source. We wanted to get a baseline working first, so we only recently shipped the source code to these things. But everything you've seen today is available publicly. The blockchain quick start, the blockchain toolkit quick start will tell you how to install all of them. And how to use them, and obviously you've seen this video. So if you're still listening, you've seen the video, so you can get information about how to do this. I'm available on the Discord server and via email. My handle is DevHawk, and I am very much a big fan of talking to customers. As an ex-Microsoft employee, I used to joke about the fact that there's this reality distortion field that sits over Redmond, and the only cure for that is to get out and talk to real customers. I don't work at Microsoft anymore, but I still live in Redmond, so I still very much believe that it's really critical to get out and talk to real customers about the stuff they're building, the tools they're using, and how we can make their lives easier on a day-to-day basis.
Awesome. Well, thank you so much for taking us through the toolkit. Rick, do you have any other questions that you want to get out before we close?
No, I don't have any questions. I just want to thank you because I think this is something is very needed for the people who were used to developing smart contracts the previous ways, using C# especially. So you have to build in Visual Studio. It's only compatible with Windows. You have to deploy using NeoCLI. You need to request guests or you use Neo Local. So this is much easier. I think you just eliminated 90% of the developer confusion that was in the beginning. So I really appreciate you for that. Thank you.
Yeah. Well, now we have to do the next 90%.
Yeah, the 10% left now, right?
No, 90% of that 10%. There's still a lot.
Oh, yes, I see. Yes.
So.
Cool. All right. Well, thank you both for your time. Thanks again, Harry, for taking us through, and for Rick for getting some good questions in and helping people explore a little bit more about what this toolkit has to offer. And thank you to everyone that has watched this video. So yeah.
Yes, thank you.
Thank you, everyone. Thank you.